Okay, 3.2. Find the measure of angle 1 and the measure of angle 2 and tell which theorem you used in each case. So let's take a look at number 1. So the measure of angle 1 is a vertical angle, so that's 117 degrees. So vertical angles theorem. Okay, and the measure of angle 2 is in a corresponding position. So that should be equal. So 117 degrees, corresponding angles theorem. So that's that one. Now that was number 1. Number 3, the measure of angle 1, and we have the measure of angle 2 here. The measure of angle 1 is equal to 122 degrees because of alternate interior angles. They're both on the inside of the two lines, and they're on opposite sides of the transversal, alternating sides. And then angle 1 and angle 2 are a linear pair, so they're supplementary. So they add up to 180 degrees. So if angle 1 is 122, then angle 2 must be 58 degrees by the linear pair postulate. You also could have said consecutive interior angles theorem. So angle 2 and 122 degrees are consecutive and they're interior. So consecutive interior angles are supplementary. They add up to 180. So either way, whatever it takes to get there. And there are the book answers to go with it. Now let's go on to number 5. Find the value of x. All right. So angle 2x and 128, those are alternate interior angles. Okay. And they're equal to each other. So we have 2x is equal to 128 degrees. So divide by 2, x is 64. All right. That's number 5. Number 7, we have 65 degrees and 11x minus 17. Those are consecutive. Remember, same side. Consecutive and exterior. And again, those are supplementary. Now, we haven't had consecutive exterior angles yet. So since we haven't had that, we probably shouldn't use it. So the reason they have angle 5 here is that 65 and angle 5 are in corresponding positions. Now, you don't have to name what you're doing, but you should be saying it every single time. Otherwise, you are really going to be hurting knowing how to do the proofs and the things we need. So angle 5, the measure of angle 5 is equal to 65 because of corresponding angles. And then the measure of angle 5 plus 11x minus 17 is equal to 180 because they are a linear pair, supplementary angles. So 65 plus 11x minus 17 equals 180. Subtract the 65 and you get 115. Add the 17 and you get 132. And divide by 11 and you get 12. No? So pause it, take a look at those answers. They're all correct. Number 9. Now the value of x. So again, you don't have anything for these two. So angle 3 is a linear pair with 8x plus 9. So the measure of angle 3 plus 8x plus 9 is equal to 180. They're a linear pair. They're supplementary. The angle 3 and 99 degrees are alternate exterior angles, so they're the same. So angle 3 must be 99 degrees. And now we substitute and solve. So 8x, 9 and 99 is 108. Subtract the 108, and you get 72. And divide off to 8, and you get 9. So x is 9. Okay, number 11. So find angle 1 and angle 2 and angle 3. All right. So we have these parallel lines. Okay, so let's do the first two here. There's two parallel lines cut by this transversal. So angle 1 and angle 2 are consecutive, but we don't know either one. All right, so let's take off that one and let's use two different ones here that has the 80 in it. So let's use these two parallel lines again, and we'll cut it by this transversal. So we have angle 3 and the measure of angle 3 and 80 degrees, those are consecutive interior angles. They're on the same side of the transversal, and they're interior. So we add them together, and they equal 180. All right, so now we can figure out the measure of angle 3. The measure of angle 3, subtract off the 80, and you get 100. The measure of angle 3 is 100. All right, so now that we know what that is, let's go ahead and start over and do this and this one and this one. So our transversal will make this blue one. So angle 2 and angle 3 are on the same side of the transversal, and they're consecutive. So angle 3, which is 100, plus the measure of angle 2 is equal to 180. Consecutive interior angles add up to 180. So we subtract 100, and we get the measure of angle 2 equal to 80. All right, so let's clean it up just a little. Let's write a couple things in here. So this is 80, and this is 100. So the measure of angle 1. So let's use these two lines, and we'll make this blue line the transversal. And the measure of angle 1, so the measure of angle 1 plus the measure, plus 80 degrees, measure of angle 2, is equal to 180, because they are consecutive interior angles on the same side of the transversal inside the parallel lines. So subtract off 80, and you'll get the measure of angle 1 to be 100. All right, so I want to point something out to you here. It's going to be a theorem coming up that if you have a parallelogram, opposite corners are congruent to each other. But you don't have that yet, but that's just something for you to remember. All right, now we go to number 13. So 3 parallel lines. All right, so angle 1 and angle 2 are corresponding angles. All right, angle 3 and angle 100 degrees, those are vertical angles. So on number 13, the measure of angle 3 is equal to 100 degrees. And angle 3 and this angle right here are corresponding angles. Alternate interior angles. And alternate interior angles are the same. So this is 100, which is corresponding with that position. So now the measure of angle 2 is supplementary to that 100 degrees. So these two are supplementary, which means angle 2 has to be 80. And the measure of angle 1 is corresponding with the measure of angle 2. Corresponding angles are equal. So the measure of angle 1 has to be 80 degrees. So there's different ways to go about doing these, and if you read both of these answers, they went through it a little bit differently on some of them. So there are multiple ways to get your answers. All right, number 15, what did they do wrong? They said the measure of angle 9 is equal to the measure of angle 10, so they're congruent, but we can look at that, and they say they're congruent because of the corresponding angles theorem. Well, they're only congruent if these two lines are parallel, and you'd have to have those two symbols I drew in there, but those two symbols aren't there, so the lines are not parallel. Okay, number 17. Oh, we didn't do 17. Number 19. So a group of campers tie up their food between 2 parallel trees. All right, so I'm going to redraw this. 2 parallel lines, and the rope is pulled very tight. So we have this transversal here, and it says this is angle 2 and this is 76 degrees. That's not 2 degrees, that's angle 2. Okay, and it says by the arcs, this is a single arc and this has 2 arcs, so they are not the same. All right, they pull it tight to form a straight line. Find the measure of angle 2. Well, these are consecutive interior angles, which means they add up to 180 degrees, or supplementary. So the measure of angle 2, if we subtract 76, we get 104 degrees. Okay. 21, critical thinking. Is it possible for 2 consecutive interior angles to be congruent? So if we look at two parallel lines cut by a transversal, so angle 1 and angle 2 are consecutive interior, and angle 3 and angle 4 consecutive interior, but those don't look like they're congruent. One is acute and one's obtuse. But if we draw a perpendicular transversal, that means that all the angles, all right angles, are congruent to each other. So that means these two consecutive angles, angle 1 and angle 2, have to be 90 degrees, and therefore they are congruent. That's the only time that they are congruent. 23. Write and solve a system of linear equations to find the values of x and y. Okay, so let's start with these two angles right here. So here's your two lines, and 5x and 14x minus 10. Those are interior, and they are consecutive. So 5x plus 14x minus 10, those are supplementary. Consecutive interior angles are supplementary. So 5x and 14x is 19x. And we add 10, you get 190, divide off the 19, and x is 10. All right, now how do we get y? So let's erase that. Well, 14x minus 10, let's draw these two transversals, or that transversal with those two lines. This is 2y. And we don't know anything else at this vertex, but we can figure out what this angle is by plugging 10 in for x. So 14 times 10 minus 10, what does that equal? That's 140 minus 10 is 130. So this is 130 degrees. And by the vertical angles theorem, this is 130 degrees. And now you have consecutive interior angles. So 2y plus 130 is equal to 180. Subtract the 130, you get 50. And divide off 2, you get 25. So 25 and 10. And there's the answer in the book. Same thing. All right. They may have done it a little bit differently, but it looked like it's close. 25. Oh, let's skip to 29 and 30 and 31. So we have to do all of these. So name a pair of perpendicular lines. So a pair of perpendicular lines. So I want to note, you have to look, first of all, to see what lines are parallel. Well, so lines, these two lines right here are the only parallel ones that there are. So now, those two lines are cut by this transversal. So we know perpendicular means 90 degrees, so we have a little 90 degree mark there. So line, this is number 29, line NP is perpendicular with QS. Oops. Okay, and now we need one more. Okay, so if that's perpendicular and those two are parallel, then this angle right here is corresponding with this angle. Corresponding angles are equal. So that means line ML is also perpendicular to line QS. Okay, now number 30. Let's erase all that, but I don't want to erase what's parallel. Okay, is QS, so let's draw this with a yellow line, QS parallel to TV? And it says explain. So the answer is no. It's obvious they're not parallel. But how do we know? It's because the consecutive interior angles have to be, if they're parallel, they have to add up to 180. And 90 and 66 do not add up to 180. And then 31, the measure of angle 1, so let's erase some of this. The measure of angle 1 and the measure of angle 2, we're finding both of those. Tell which postulates or theorems are used. All right, so angle 2 and 66 degrees are a linear pair. Okay. And so they add up to 180 degrees. So 66 plus angle 2, measure of angle 2 equals 180. Subtract the 66, so the measure of angle 2 is equal to 114 degrees. And angle 1 and angle 2 are corresponding. So the measure of angle 1 is equal to the measure of angle 2. So they're both 114 degrees. Okay. 34 and 35. Factor. So let's start with 34 here. Anytime you have four terms you factor by grouping. So there's a group and there's a group, the first two and the last two. What can we factor out of the first two? A t squared, and we're left with t minus 5. And let me write this out a little bit nicer for you. So t cubed minus 5t squared. We're going to factor out t squared. When you factor, what you're really saying is you're dividing both of them by the same value. That's what factoring one thing out of multiple terms is. So if I actually divide both those by t squared, I have a t to the first left and a 5 left in the second term. And then I look at the second group here, I have a plus 3t and a minus 15. I can divide both of those by a positive 3. So I'm going to put a positive 3 out here, divide them both by 3, and see what I get. That's a t and a minus 5. So factoring by grouping, that's what factoring is. And we do the next step, and this term has a t minus 5 in it, and this term has a t minus 5 in it. So I'm going to factor both of these by the t minus 5. So I'm going to factor again. So if I divide that whole thing by t minus 5, and this whole thing by t minus 5, the t minus 5's reduce out, and I'm left with t squared plus 3. That's factoring by grouping. Number 35. I can factor a 4 out of both of these and an x squared. They both have an x, and if you're looking for exponents, you take the smallest one. So if I divide both of these by 4x squared, because that's what factoring is, then the 4 is reduced to 1, and the x to the fourth over x squared reduces to x squared. And the x squareds reduce out on the second side here, and 36 divided by 4 is 9. And that would be your answer, with the exception that you should realize that this is the difference of squares. The x minus 3 times x plus 3. If I were to distribute that back together with FOIL, that would give me x squared minus 9. So these should be the two answers that the book gives. As you can see, that's what we have. All right, last question. Find the x and y intercepts. So this is a skill to have. So to be able to find the x and y intercepts, we need to understand what that is asking. So when you're looking for the x-intercept, that is when y is 0. You plug 0 in for y and see what you get. 7x minus 4 times 0 is equal to 28. Well, 4 times 0 is 0, so we have 7x equals 28. Divide off the 7, and x equals 4. So the x-intercept is at 4, 0. And to find the y-intercept, anytime, if we're looking at this, okay, so 4, 0. The y-intercept, let me draw it here. Plug 0 in for x, 7 times 0 minus 4y equals 28. Now be careful. 7 times 0 is 0. Do not drop that minus sign. That becomes a negative 4. And now we divide off the negative 4. Y equals negative 7. 1, 2, 3, 4, 5, 6, 7. All right, so here's this line. Visually, you didn't have to graph it, okay? But in order to find the x and y intercepts, what I wanted to show you is where it crosses the x-axis, the y value is always going to be 0. Where it crosses the y-axis, the x value will always be 0. So if you just plug those in, you can get your x and y-axis intercepts and just connect the 2 points, and you have your line. You don't have to put it in slope-intercept form. All done.